Coral reefs are the most biodiverse marine ecosystems in the ocean. Some studies estimate that they hold as much as 25% of all marine life. They also happen to be one of the most fragile ecosystems on Earth, as they are affected by many things such as water temperatures rising, carbon emissions, overfishing, coastal development, and cruise ships dumping their reused water, which we will be focusing on. Coral reefs have a complicated structure, but are mainly built on a symbiotic relationship between zooxanthellae, an algae, and coral polyps. The algae live in the tissues of the coral and produce carbohydrates and oxygen for the coral. This relationship allows coral polyps to grow by excreting a calcium carbonate skeleton. Calcium carbonate is a base for the entire reef, so rising ocean acidification, which lowers carbonate saturation levels, hurts polyps' ability to grow and leads to bleaching. Once settled and grown, coral polyps will then shoot their larvae into the ocean to float about until finding a rock or other coral to attach itself to. The rest of the coral reef ecosystem is filled with a variety of roles and symbiotic relationships. There are anemones, which help protect different fish and crabs, as well as bottom-feeding fish that clean detritus and even convert zooxanthellae into sand. Coral reefs are amazing systems, and the greatest of all is the Great Barrier Reef, located off the coast of Queensland, Australia. It is actually an amalgamation of 2,900 different reefs and covers 133,000 square miles. It is the world's largest structure made by living organisms and is even viewable from space. Despite this, the GBR has lost more than half of its coral since 1985 and shows large swaths in the south of the reef that are completely dead. This is not an uncommon situation either, as 60% of reefs are damaged by overfishing and pollution, while 75% are listed as threatened.
An area that we need to discuss for pollution with these coral reefs is cruise ships dumping their gray waters into the ocean. To begin, cruise ships' gray water is the water that is left over from the showers, baths, sinks, toilets, and the laundry facilities from all of the crewmates and passengers aboard the ship. If this is untreated, many of these gray waters can grow and contain bacteria, pathogens, many different types of oil and grease, metals, and other forms of waste. Most cruise ships contain vessels that hold this wastewater until full. However, U.S. law dictates that once cruise ships are more than 3 miles away from the shores, they are allowed to dump their waste freely into the ocean. This is because in open waters there is no federal laws that can be dictated to these vessels. There are, however, guidelines that all cruise ships are supposed to follow, but this is not the case in some cruise ship companies. It is estimated that cruise ships dump around 1 billion gallons of gray water into the ocean every year. Some cruise ship companies have developed methods to reduce their waste dumped into the ocean through advanced sewage systems. This has been in the works from the early 1960s to the present day. However, this only affects roughly 60% of the damage that is done, and the quantity of the gray water dumped from these cruise ships is still the same. This impacts both the environmental and socioeconomics and needs to be further explored so that damages to these coral reefs can be minimized in the future.
Most cruise ships generally collect and treat sewage in one or two variety of ways. A biological system employing aeration and clarification to biologically digest wastewater, or a chemical treatment system that masticate the waste and add up 8 times the volume of salt water and chlorine. Following the treatment, the waste is pumped into a holding tank where it is usually combined with the ship's gray water. These wastes are held until discharge overboard. Dilution is a secondary natural treatment in the ship wake region, which occur after wastewater discharging. According to EPA, the natural treatment process is quantified by dilution factor, which is strongly dependent on vessel's width, draft, speed, and wastewater discharge rate. Since chlorine itself is a highly toxic substance, especially to the eggs and larvae of many marine organisms, the chlorine that enters the receiving water upon the discharge of the waste can have significant environmental impact. Eutrophication is the result of a particular type of marine pollution caused by the release of excess nutrient like nitrogen and phosphorus into coastal water. Nutrient enrichment in coral reef system can contribute to direct impacts such as loss of coral diversity, structure and function, including phase shift to a macroalgae-dominated system, and may make indirect impacts such as increased coral disease or reduced reproductive success. High availability of dissolved inorganic nutrient can lead to significant physiological changes in corals, such as decreased calcification rate and higher concentration of photopigments, but generally does not lead to mortality. Eutrophication has also been found to hamper coral gametes production, altering the timing of spawning and decrease fertilization success, and can also decrease the survival of coral recruits. The indirect effect of nutrient enrichment on coral can include enhanced macroalgal productivity and growth that competes with coral for substrate and increased phytoplankton productivity. Excessive phytoplankton productivity can result in extreme population increases that reduce benthic light availability for both corals and reef seagrasses, or may lead to high organic matter concentration in the water column and in sediments. Corals in nutrient-enriched or turbid water appear more vulnerable to temperature stress than those in low-nutrient environments. A major long-term effect of increased loads of nutrient in coral reef is postulated to be the triggering of population of the coral-eating crown-of-thorns starfish, which kills significant areas of corals on reefs. Evidence suggested that the survival and growth of crown-of-thorns starfish larvae is enhanced by increasing concentration of large phytoplankton that are dependent on the availability of dissolved inorganic nitrogen and phosphorus, or naturally enriched nutrient conditions. Many studies have shown that increased nutrient from terrestrial sources can contribute to increased incidence of coral disease. Nutrient-rich discharges from cruise ships can directly affect the microbial composition of reef environments and cause increased populations of potential pathogens on coral colonies. Reducing nutrient derived from anthropogenic sources is therefore a prime target to mitigate the impact of coral disease.
Cruise ship greywater dumping around the Great Barrier Reefs also has severe socio-economic consequences. Healthy coral reefs offer remarkable benefits for the economy, however, these benefits decrease with coral reef degradation. The Great Barrier Reef is a critical economic and social asset for Australia, providing immense economic, social, and brand value for the country. According to Delight, the Great Barrier Reef has an overall asset value of approximately $56 billion. And in 2015, the reef provided over 64,000 full-time jobs and $6.4 billion to the Australian economy. This economic contribution was brought in mainly through tourism, but also through recreational activities, the commercial fishing industry, and scientific research. Research showed that in 2015, over 65 million people visited the region, spending on average about $127 a day. The region's residents also utilized the reef for recreational activities, such as boating, fishing, sailing, and visiting the islands. Commercial fishing and aquaculture industries thrive in the reefs region, boosting income in coastal communities and playing a crucial role in Australia's seafood industry. Reef degradation due to cruise ship greywater can lead to a loss of tourism and recreational revenue and fishing livelihoods. Besides economic value, people value the reef for other various reasons. On an international level, some reasons include being important for the planet and for biodiversity, for future generations, moral and ethical reasons, the tourism industry, and the world not being the same without it.
The majority of cruise ships sailing around the planet have an advanced water treatment plant. There are many different types of treatment plants, but the most common and most widely used is a bioreactor treatment plant. These bioreactors have bacteria cultures inside that feed on the solid waste, leaving clumps of bacteria in a permeate. The permeate is filtered out, exposed to UV light to kill off excess bacteria. Chemicals are then added to clean and detoxify further, and finally the permeate, which now passes drinkable standards, is dumped into the ocean. A state-of-the-art bioreactor, known as the Xenon bioreactor, is used by Holland America Cruise Lines, which operates around Alaska, Canada, and Washington.
The xenon reactor, known as the Seaweed 500, is used by these cruise ships. Wastewater passes through multiple membranes which remove biological waste, harmful chemicals, cysts and oocysts, and bacteria. The filtered out wastes are stored on board until the ship reaches a terminal where the waste can be sent to a proper waste facility and be disposed of. The water that is left over after passing through the bioreactor is also considered drinkable, but is dumped into the ocean outside of certain regulation zones in Alaska. Another treatment process uses hydroprocessors, which separate food from wastewater, which do not directly contribute to gray water, but can be considered a harmful waste that is often dumped into the ocean. Hydroprocessors separate solid food waste through many different membranes, allowing the water to flow through while the food contaminants are caught, stored, and dried out. This byproduct is then incinerated on board to reduce the waste. Another way that cruise lines are trying to combat their gray water waste is to retrofit older cruise ships with modern water treatment systems. A lot of ships built before 2012 were not equipped with systems that can handle the waste load produced on board. These ships are being fitted with systems that can treat this waste problem in order to abide with regulations set within the company and in regulated waters. Regulations are in place for authorized dumping. However, it is very hard to monitor, and some cruise lines have taken advantage of this. Many cruise lines have been fined in the last decade for their dumping, but that is only the unregulated dumping that is known of. Some regulations include you cannot dump untreated gray water within 12 miles of land, treated gray water within 3 miles of land, and you must be traveling at 6 knots in order to disperse the gray water and dilute it in ocean water.
Unless something is done about the gray water expulsion from cruise ships, the ecosystem of the Great Barrier Reef will continue to break down. As for the future of the Great Barrier Reef, there are only 3 possibilities. First, that enough change is made so that the destruction of the ecosystem is either stopped or reversed. The second is that the damage to the ecosystem continues, but the plants and animals that comprise the ecosystem can adapt to the changes. And the third is that nothing is done and the ecosystem continues to deteriorate. As it's not likely for the flora and fauna to mutate rapidly enough to their needs in their new environment, it is vital that human behavior change. Solutions that show merit but need further development or action include making gray water treatment more affordable and sustainable, granting the same protections that MARPOL Annex 4 grants to land to the Great Barrier Reef, reducing or eliminating cruise ship access to waters near the Great Barrier Reef, and developing systems or methods to clean up gray water once it's in the reef.